All right, let's talk about something that might be a huge hidden risk in your supply chain. We're diving into a critical update to an electronics packaging standard, and trust me, if you're not on top of this, it could be costing you big time.
So, let me ask you this. That anti-static packaging you rely on, to protect your most sensitive, most expensive components, what if it only really works under perfect lab conditions? Because when that stuff fails out in the real world, well, the consequences can be absolutely catastrophic.
Okay, so first up, let's talk about the old standard. We're going to pull back the curtain and uncover this really dangerous loophole that created a massive, and I mean massive, blind spot for manufacturers everywhere. It's a real problem.
So here's the absolute core of the change, right? The old standard, you can think of it like a friendly suggestion. It was a guide, sure, but it had a ton of gray area. The new 2021 standard, nope, it's a strict technical requirement. It's basically the difference between someone saying, you probably should do this, and a sign that says, this is the law. No wiggle.
And this is where that gray area became so dangerous. Look at this. Under the old rules, a material could sail through testing in a nice, controlled factory environment. Let's say 50% relative humidity. Boom, green check mark, it passes. Everything looks great, right?
Wrong, because, and you really need to get this, that exact same material, the one that just passed with flying colors, becomes a dangerous static-generating insulator the second it hits a dry environment. Think about an airplane's cargo hold where the humidity just tanks. It literally flips from being a protector to a threat. That right there with the fatal flaw.
So, how did the 2021 standard fix this massive problem? Well, it did it with one golden rule. A single, crystal clear, unambiguous rule that completely changes the game.
What they did was introduce a super strict definition for what they call static dissipative packaging. All that means is it's material designed to safely pull static charges away from your sensitive components. And to do that, they set a precise, absolutely non-negotiable range for something called surface resistance. This one move just, poof, eliminated all that dangerous gray area.
And here it is. This is the heart of the whole update. The absolute upper limit for surface resistance is now mandated, not suggested, mandated, to be less than 1.0 times 10 to the 11th ohms. And those two words less than, they change everything. This is the kind of crystal clear detail we need.
Yeah, there's just no more ambiguity. It's not about or approximately 10 to the 11th. There is absolutely, positively no room for negotiation. That number is a hard ceiling. It is not up for debate. End of story.
So you're probably wondering, okay, why that specific number? Why 10 to the 11th? Well, you can bet it wasn't just pulled out of a hat. It's based entirely on the science of how these materials actually behave under real-world stress.
The science is pretty clear on this. What the experts found was that materials with a resistance right on the edge of that old spec, between 10 to the 11th and 10 to the 12th ohms, are just dangerously unstable. They're great at 50% humidity, but the moment things get dry, they turn into insulators. The whole point of the new standard is to get rid of this fair weather packaging that looks good in the lab, but fails you when it actually matters.
And what this new rule does is, well, it effectively forces the entire industry to move on from those cheaper, unstable materials. The only way forward now is to use materials that are permanently static dissipative, materials that you can count on to work no matter the conditions.
Okay, so this brings us to the new testing protocol. And this is really important because it makes a huge distinction between packaging you use inside your own factory and stuff that's actually getting shipped out the door.
The rule is actually super simple. Look, if the packaging never leaves your building, you've got a little flexibility. You can test it at whatever your factory's lowest humidity level is, fine. But the second a package is meant for shipment, all bets are off. There are zero exceptions. So, let's make this perfectly clear. The bottom line is this. Every single piece of packaging that leaves your facility must pass that super strict 12% relative humidity test, period. No exceptions, none.
All right, so with all that said, what does this actually mean for you? What should you be doing right now to make sure you're compliant? Let's break it down.
Here's your 5-step plan to get this handled. Number 1, update your company's internal packaging plan. Do it now. 2, demand new test reports from all of your suppliers and make sure they specifically call out the 12% RH condition. 3, you need to verify that data yourself. Make sure it proves the surface resistance is safely under that 1.0 times 10 to the 11th ohms limit.
4. You've got to separate how you manage your in-house packaging versus your transport packaging. They are not the same anymore. And finally, number 5, train your incoming quality control team, your IQC folks, so they know how to validate every new material that comes in the door against this new, tougher standard.
Look, at the end of the day, this update is so much more than just a number on a spec sheet. It's a fundamental shift in thinking. It's about guaranteeing your product is actually safe, from the moment it leaves your factory floor to the moment it gets into your customer's hands. So the real question you need to leave with is, are you really sure your entire supply chain is compliant with these 2021 regulations?